Chapter 1, Overview. What is the origin of the nuclei found on Earth? Nuclear scientists carry out both theoretical and experimental investigations using high-energy accelerators, innovative detectors, and forefront computing facilities. A walk around the chart. The nucleus. 1. The atomic nucleus consists of nucleons, protons and neutrons. Protons and neutrons are made of quarks and held together by the strong force generated by gluon exchange between quarks. In nuclei with many nucleons, the effective strong forces may be described by the exchange of mesons, particles composed of quark-antiquark pairs. A proton consists of 2 up quarks and 1 down quark along with short-lived constituents of the strong force field. A neutron is similar except that it has 2 down quarks and 1 up quark. Although scientists are convinced that nucleons are composed of quarks, a single quark has never been isolated experimentally. Energy brought into a nucleus to try to separate quarks increases the force between them. At high enough energy, the addition of energy creates new particles rather than freeing the quarks. Chart of the nuclides. 2. The chart of the nuclides shows the known nuclei in terms of their atomic number, Z, and neutron number, N. Each box represents a particular nuclide and is color-coded according to its predominant decay mode. The so-called magic numbers, with N or Z equal to 2, 8, 20, 28, 50, 82, and 126 correspond to the closure of major nuclear shells, much like the atomic shells of the electrons, and enhance nuclear stability. Isotopes that have a magic number of both protons and neutrons are called doubly magic and are exceptionally stable. Radioactivity. 3. Atoms are radioactive if the protons and neutrons in the nucleus are configured in an unstable way. For low numbers of protons Z, the number of neutrons N required to maintain a stable balance is roughly equal to the number of protons. For example, there are 6 protons and 6 neutrons in the nucleus of the most abundant form of carbon. 4. Large numbers of protons in the nucleus, the repulsive electric force between protons leads to stable nuclei that favor neutrons over protons. One stable nucleus of lead contains 126 neutrons and 82 protons. A radioactive atom, lacking a proper balance between the number of protons and the number of neutrons, seeks a more stable arrangement through radioactive decay. These decays occur randomly in time, but large collections of radioactive materials have predictable mean lifetimes. The common decay products are named after the first 3 letters of the Greek alphabet: alpha, alpha, beta, beta, and gamma, gamma. In an alpha decay, a helium nucleus escapes from a nucleus. Alpha emission reduces the number of protons by 2 and also the number of neutrons in the nucleus by 2. Beta decay can proceed either by emission of an electron and an antineutrino or by emission of their antiparticles, a positron and a neutrino. Beta decay